So we are told that the current across a 5 microfarad capacitor is 2 cos 50,000 amperes. And prior to that, there was no current across the capacitor, and we are required to find the voltage across the capacitor and the maximum power delivered to the capacitor at any point in time. We are also required to find the maximum energy stored in the capacitor at any instant in time. This is all easy once your background of calculus is quite solid. You know that I is equals to C dV dt. So we can just say that I over C, integral I over C is equals to V. We can write this as 1 all over C integral I dt plus some initial conditions I 0, which is actually equals to 0 in this case. Yeah, it is specified here. So okay, let us integrate 2 cos 50,000 t. So we know that integral, let's do that here, I dt equals integral 2 cos 50,000 t dt. If we proceed to do our integration, we would have it that this is equals to 2, we bring out this 2 over 50,000 sine 50,000 t. So that is the value of I dt. We can write this as 1 all over 25,000 sine 50,000 t. We know the value of I dt. We can then substitute it there, and we would have it that V equals 1 over 5 times 10 raised to the power minus 7 multiplied by 1 over 25,000 sine 50,000 t. With the help of a calculator, we can arrive at 80 sine 50,000 t. That is quite simple, quite simpler than the previous example. So we are done with this. We know the value of the voltage, that is V of t is equals to 80 sine 50,000 t. Next, we are required to find the maximum power delivered to the capacitor at any point in time. To do that, we know that P power is equals to IV. So we know the current 2 cos 50,000 t and the voltage 80 sine 50,000 t. So that would make it 2 times 80, 160 sine 50,000 t cos 50,000 t. Okay. Next thing to do would be to figure out at what instant will the power be maximum. So in order to do that, we need to differentiate the power and equate the value to 0. and the value of t that we get would be the point at which the power is maximum. And do this differentiation with the help of the chain rule. Let's say r is equals to 160 sine 50,000 t, and s is equals to cos 50,000 t. The r, the t would be equals to 160 cos 50,000 t, and the s, the t will be equals to minus sine 50,000 t. Okay, and we can just use the chain rule formula, and that would lead us to the p, the t to be equals to this multiplied by this. That would be minus 160 sine squared 50,000 t plus 160 cos 50,000 t. Okay, we can factorize 160 out, and we have 160 into cos squared 50,000 t minus sine squared 50,000 t. If you are familiar with your trigonometric identities, you realize that this is a double angle identity. So we can rewrite this as 160 cos 100,000, that is 2 times 50,000, 100,000 t. If you don't understand this, you should look up your double angle identities. Then now that we have the p dt, we can equate it to 0. So at p maximum, 160 cos 100,000 t equals 0, and that would mean that cos 100,000 t equals 0, and if we take arc cos of 0, we would have it that 100,000 t is equals to pi over 2, and that means that t is equals to pi over 200,000 seconds. The next thing to do would be to substitute this into this formula, and we'll get the maximum power delivered to the capacitor at any point in time. If we were to do that with the help of our calculator, put this value inside here with the help of our calculator, we would arrive at P maximum to be equals to 80 watts. You can try that on your own. The last part of the question requires us to calculate the maximum energy stored in the capacitor at any point of time. Okay, we take the same approach, except this time the rate of change of energy with respect to time is power. So say the P, the W, the T, which is equals to P. So we equate it to 0, and the value of T at that point in time, we substitute it into V. I would say W is equals to half CV squared. Of course, we could go the long way of integrating P and then substituting it, but that is quite inefficient. So let's just do this. So 160 sine 50,000 t cos 50,000 t equals 0. That is at our maximum energy. So there are two possible solutions. One gives the minimum power, the minimum energy stored at any point in time. The other gives the maximum energy stored at any point in time. So if we divide both sides by sine by 160 cos t, we would arrive at sine 50,000 t equals 0. And if we take arc sine of both sides, we arrive at 50,000 t equals 0. That is t equals 0. And we can also take divide both sides by 160 sine t, 160 sine 50,000 t, and we would arrive at cos 50,000 t equals 0. Which if we take the arc sine of both sides, we arrive at 50,000 t equals pi over 2. Okay, then t equals pi over 100,000. Yeah, t equals pi over 100,000. So this is the second possible value for t. Now you can then input it into v and see the value that is largest. That would be the value at which the energy is maximum. If we substitute this value in this function, we get that v of 0 equals 0 volt. And if you were to substitute this value in this function with the help of your calculator, you get v of pi over 100,000 equals 80 volts. So we can just go on and say that W is equals to half C V squared, and in this case that would be half multiplied by 0.5 times 10 raised to the power minus 6 multiplied by 80 squared, and that would be equals to 1.6 millijoules. Yeah, and this is the maximum energy that can be stored in the capacitor at any point in time. And that will be all for today. Thank you for watching. See you next time. Bye.